Imagine you are floating in complete darkness, not the darkness of a power outage, not the darkness behind your closed eyes. This is the darkness between stars, absolute, total, ancient. The nearest light source is so far away that its warmth will never reach you. The nearest sound is nothing, because sound doesn't exist here. You are 48 light years from home, and beneath you, slowly rotating, is a world that should not exist. It has a surface, solid ground, rock you could theoretically stand on, but if you tried, you would be dead before your foot touched it. 3 days ago, for the first time in the history of human civilization, we looked at that surface. Not from a probe, not from a flyby, from a telescope 1.5 million kilometers from Earth, and what we found has quietly rewritten everything we thought we knew about planets beyond our solar system. This is not a drill. This actually happened. And if you think this story ends with a simple discovery, stay with me. Because what we didn't find is somehow more terrifying than what we did. If this kind of content makes you feel beautifully small and utterly terrified, you are in the right place. Subscribe before this video ends, because when the follow-up data comes in, you are going to want to be here for it. Let's start with the planet itself, because you need to understand what we're actually looking at before you can appreciate how deeply strange this is. Its name is LHS 3844b. That name tells you almost nothing. So let me translate it into something you can feel. It is a super-Earth. That means it is made of rock, real, solid, geological rock, just like the ground beneath your feet right now. Not a gas giant swirling with storms, not a ball of ice, rock, 30% larger than our entire planet. And it is sitting 48.5 light years from where you are standing. To put that into perspective, the closest star to our sun is about 4 light years away. This world is more than 10 times further than that. If you boarded the fastest spacecraft humanity has ever built and pointed it at LHS 3844b, you would arrive in approximately 800,000 years. Your entire bloodline, your entire civilization, every language ever spoken on Earth, none of it would exist by the time you got there. And yet 3 days ago, we read its geology from here. But before we get to how, you need to understand what this planet is actually like. Because this is where the beauty starts to curdle. Picture a world from above. Dark, smooth, ancient. No oceans, no clouds, no weather systems spinning across its surface. From a distance, it might look almost peaceful, the kind of alien world you'd imagine in a science fiction film. Still, quiet, waiting. But here's the problem. This planet orbits its star not in 1 year, not in 1 month, but in 11 hours. 11 hours! It is so impossibly close to its sun that it completes an entire orbit in the time it takes most people to sleep, wake up, and get through half a workday. At that distance, something happens that changes everything. The planet becomes locked. Tidally locked, meaning the same face of the planet points toward its star forever. Always. For billions of years, one side of this world has been staring directly into a sun. It has never experienced a sunrise. It has never experienced a sunset. There is a side of this planet that has been burning continuously since before complex life existed on Earth. The temperature on that dayside? 725 degrees Celsius. 1,340 degrees Fahrenheit. That is 4 times hotter than the highest setting on your oven. Hot enough to melt lead. Hot enough to turn certain metals into vapor. And the other side? The permanent night side? We don't fully know, because here's the thing about a world with no atmosphere. There is nothing to carry the heat around. No wind, no weather, no transfer. The dark side may be hundreds of degrees colder. The boundary between the two halves of this planet could be one of the most violent temperature gradients in the known galaxy, a line where you would roast on one step and freeze on the next. But it gets worse. There is no atmosphere. None. Whatever gases might have once wrapped this world have been stripped away. blasted off by the constant radiation of a red dwarf star at point-blank range. Red dwarfs are deceptive. They look small and dim and harmless. But they are not harmless. They are violent. They erupt in flares that would sterilize an unprotected surface in minutes. They bathe nearby worlds in ultraviolet and X-ray radiation constantly, relentlessly, for billions of years. LHS 3844b has been sitting inside that radiation bath since before our solar system finished forming. The surface is not just hot, it is irradiated, bombarded. Every square centimeter of the dayside has been absorbing the equivalent of a cosmic blowtorch for longer than Earth has had oceans. If you were standing on it, which again, you cannot, you would die before you arrived, you would not need to worry about the heat killing you first. The radiation would get there faster. No magnetic field to protect you, no atmosphere to absorb the blast. Just you, the rock, and 4.2 billion years of accumulated stellar punishment raining down from above. And this is where things change, because despite all of that, despite everything this planet has endured, it still has a surface, it still has geology. And 5 days ago, for the first time in human history, we figured out how to read it. The James Webb Space Telescope has been staring at the universe since 2022. You have seen its images, the deep fields, the dying stars, the galaxies forming at the edge of time. But this is something different. To read the surface of a world 48 light-years away, without a probe, without a lander, without any physical contact whatsoever, the team did something almost absurd in its elegance. They watched the planet disappear. When LHS 3844b passes behind its star, what astronomers call a secondary eclipse, the total brightness of the star system drops slightly. That drop is the planet's contribution being removed. The heat the planet was radiating into space, gone for a moment, then back again. And in that difference, that tiny, almost imperceptible signature of heat, is a fingerprint. Different types of rock emit heat differently. Basalt glows one way, granite glows another. Silicate minerals have their own thermal signature. It is like being blindfolded in a dark room with a fireplace across from you. You cannot see it. But if you pay close enough attention to the warmth reaching your skin, you can tell whether it is burning wood, coal, or gas. Each one feels different in a way that is real and measurable, even in the dark. The JWST team used the telescope's mid-infrared instrument, MIRI, to take exactly that measurement. Not once, 3 times across 2023 and 2024, observing 3 separate eclipses to confirm what they were seeing was real. The result was published 4 days ago in Nature Astronomy. And what they found sitting on the surface of this baked, irradiated, airless rock world 48 light-years away is something you have actually seen before. Dark basaltic rock, the same material that makes up the floors of Earth's oceans, the same black volcanic rock that cooled from magma on Hawaii millions of years ago, the same dark crust that covers the ancient plains of the Moon, the same surface that NASA's Mariner probes photographed on Mercury 50 years ago. When the scientists compared JWST's heat readings to laboratory samples of known minerals, the closest match was basalt. Dark, iron-rich, dense volcanic basalt, the most common rock in the inner solar system. The lead researcher said it simply: "We see a dark, hot, barren rock, devoid of any atmosphere." And for a moment, that sounds almost disappointing, almost ordinary. We looked across 48 light-years at an alien world and found something familiar. But that's not even the worst part, because we don't know how it got there, and the 2 theories are both, in their own way, deeply unsettling. Theory 1. This planet is covered in fresh volcanic basalt. Something erupted, recently in geological terms, and resurfaced the entire world. New lava flows cooling into dark rock, coating everything that came before. If that's true, then this planet is not dead. It is active. It has geological energy still churning beneath its surface, which means it has a hot interior, which means it may have had, or still have, the conditions for something we associate with life. Not life itself, but the preconditions, the raw geological machinery. But here's the problem. JWST found no carbon dioxide, no sulfur dioxide, no volcanic gases at all. The kinds of gases that pour out of every active volcano on Earth were completely absent. If this planet is actively erupting, it is doing so in a way that violates everything we understand about volcanism. Theory 2. The surface is ancient. The basalt has been there for billions of years, and what JWST is reading is not fresh rock, but pulverized wreckage. Micrometeorites raining down for eons. Radiation breaking down the crystal structure of rock into fine dark powder, regolith. The same grey dust that coats the surface of the moon, the kind of powder that Neil Armstrong's boots sank into in 1969. If the surface is regolith, then this planet has been dead for a very long time. Slowly ground down, slowly darkened, passively accumulating the scars of 4 billion years of cosmic violence. And we cannot yet tell which it is: solid slab of volcanic rock or ancient powder. The next round of JWST observations will look at the surface from different angles, because solid rock and loose powder emit heat differently depending on the viewing angle. The answer is coming, but in the meantime, sit with the fact that we are debating the geological history of a world nearly 500 trillion kilometers away, and that we have the tools to actually resolve the debate. Here is why that matters in a way that should genuinely unsettle you. For 30 years, exoplanet science meant one thing: atmosphere hunting. We looked for gas signatures around distant planets, hoping to find oxygen, methane, water vapor, the chemical fingerprints of life. It was the only tool we had, the only window we could see through. But atmospheres require certain conditions. Rocky planets close to active stars don't have them, which meant an entire category of worlds, scorched, irradiated, airless super-Earths, were essentially invisible to us. We could detect them. We could measure their size and orbit, but we couldn't see inside them. LHS 3844b just broke that wall down. We are now in the era of exoplanet geology. We can classify distant worlds not just by their size or the gases around them, but by what they are made of, by the history written in their rock, by whether a world was ever geologically alive, ever had the machinery to support chemistry, ever had a past worth investigating. Think about what that opens up. In 1995, we found the first planet orbiting another star. In 2016, the first hints of an exoplanet atmosphere. In 2026, the first surface. The pattern is not random. Each decade, we peel back one more layer. Each decade, distant worlds become a little less alien and a little more knowable. The 2030s will bring NASA's Habitable Worlds Observatory, a telescope designed specifically to image Earth-sized planets in the habitable zones of sun-like stars. The techniques proven on LHS 3844b are the blueprint. The same method, applied to a world at the right distance, the right temperature, the right size, could one day tell us not just what a planet's surface is made of, but whether its geology looks anything like ours, whether it has the right kind of rock for liquid water to interact with, whether it has a crust that could have supported chemistry, whether the surface of a world light years away carries any trace of the conditions that, on one small blue planet, eventually produced everything that has ever thought about the universe. The next JWST observations will answer one question: solid rock or powder? If it's powder, this world has been slowly dying for billions of years, ancient, passive, ground into dust by the cosmos. If it's solid basalt, something happened more recently. something geologically alive left its mark. Either answer is a first. Either answer tells us something we have never known about a world beyond our solar system. And either answer brings us one step closer to knowing whether any rocky world out there could have ever supported something more than rock. The universe is 13.8 billion years old. We have been asking this question for about 100 years. We are just getting started. If this hit differently than you expected, if you are sitting there feeling genuinely small right now, that means it worked. Drop a comment below. Solid rock or regolith? What is your gut telling you? And if you are not subscribed yet, do it now, because when the answer comes in, I will cover it the hour the data drops. You do not want to find out from someone else. Like the video if this changed how you think about what a telescope can do. Share it with someone who thinks space is just pretty pictures. It is not just pretty pictures anymore. We are reading alien geology, and we are only getting better at it.